This is week 8's advanced concept interactive presentation. So I have here a cup of sand and the dish soap and cornstarch. And I also have here a cup of water and a bowl to mix these things in. So first, I put the sand in the bowl. And then I'm going to add a half of a tablespoon of cornstarch. And mix that together. It is important for this cornstarch to be mixed in fairly uniformly and thoroughly, because it will have an effect on the texture that the sand takes on. Okay, then we're going to add in the dish soap. So we need a teaspoon of that to start with. Okay, and hold this up here a little bit. I'm going to start to stir this together. Right away, it does start to make the sand kind of stick together, which is what we want. This is at least the beginnings of polymerization, which is when monomers that are much smaller molecules combine with each other chemically in order to form long chains. In the case of commercially made kinetic sand, those long chains are made of something called silicone, not just silicone like the element on the periodic table, but put an E on the end of that. And those silicone oils are made of silicone, the element, and oxygen that are in repeating units that make these long chains that ultimately make this sand start to stick together. Now this is still pretty dry. It's kind of crumbly, but not really exactly what we want it to be just yet. So take this straw and we'll start to add in just a little bit of water at a time to help moisten it up just a little bit. These silicone oils, which our soap is acting like that in this case, can act like a liquid, like most oils. They can act like a semi-solid when there is pressure involved. And with kinetic sand, we end up with a rubber-like texture, and that's called viscoelasticity. So the degree at which that happens depends on the length of those silicone chains in the case of kinetic sand. The water is helping a little bit, and you've got to remember that that cornstarch is in there, which also helps thicken the water. So this combination of soap and the thickened water work together to make this sand stick together, and that kind of limits the sand's ability to move freely on a granule level. And that's why it ends up being called kinetic, because it is dealing with the movement. And this is getting still a little more rubbery, I guess we could call it, but it's still really pretty dry. So we'll put in a little more water and see. We don't want it to get too much water and too runny, but if it does, we can add a little more cornstarch, and that should help reverse that effect a little bit. So this is gradually changing texture. It's not just grainy sand anymore. And it's not really a quick process to get it to act more the way we want it to act. Add a little more water. We'll add a little bigger amount this time and see if we can move it along just a little bit. There we go. That is a lot better. So it does look much more like something rubbery. Nowhere near as grainy. Okay. So this does work. This might be just a little bit wet, but it is working to hold the sand together in these long chains, and it limits the motion that the individual grains can have. So, if we let this sit for a while, it would eventually re-flatten out and be less of a ball. But it does work. Thank you.